Simply, rank of a matrix means that is a non-zero matrix you take. Let A be the non-zero matrix. For that matrix, it is of order m by n. Okay, so it is the maximum order of the square submatrix, that non-singular square submatrix is called as rank of a matrix. Okay, so for example, you have a matrix of let us say 3 by 4 matrix you take. Okay, 3 rows and 4 columns. Okay. 3 rows means like A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, D3, C3. So it is a 3 by 4 matrix. For this 3 by 2 matrix, it is the highest order of the thing. Like, is it possible to take 4 by 4 square matrix here? No, it's not possible. We should take 3 by 3 square matrix. Okay. So the 3 by 3 square matrix, if all the 3 by 3 square matrix determinant is like it is not 0. Sorry, we take the 3 by 3 square matrix. If any one, at least any one of the 3 by 3 matrix is non-singular. Non-singular means that determinant of the submatrix is not 0. Then we declare the order is, the rank is 3. Yes. We can take, that's what I said. Possible number of 3 by 3 is there. We can take first 3, or you can take last 3, or you can take first, second and last. Okay, or you can take this last, this and first. Okay, like with any 3 by 3. But the thing is, at least one 3 by 3 matrix should have should be non-singular. Okay, non-singular means their determinant should not be equal. Suppose the determinant is 0 for all the 3 by 3, then we should go for 2 by 2 matrix. If you find at least one 2 by 2 matrix is non-singular, the order is, the rank is 2. Okay. Suppose all the 2 by 2 become 0, the rank is not 2, then it is 1. That's why I gave you one remark, remember, like in the previous class. The rank of a matrix is what? Which is less than or equal to minimum of m and n. Did I said or not? So for this matrix, the rank will be less than or equal to minimum of 3 and 4. Which is minimum of 3 and 4? Whether 3 is minimum or 4 is minimum? 3. That means the rank will be less than or equal to 3. So if all the 3 by 3, at least one 3 by 3 not become 0, the rank is 3. Or else we go for 2 by 2 and the procedure continues. Okay, this is what the procedure for rank. Whereas we can use elementary row transformations. Elementary row transformations or elementary transformations. It is not elementary row transformations. So elementary transformations means elementary, like each element we are transforming into something. How means we'll take any one of the row. Okay, and in that row we'll write the answer. Like that row can be added or subtracted with some other row, or that can be multiplied with some other row. This we have seen before itself, right? Where we have seen echelon form. Properties of determinant we have seen, right? So after this also, this elementary transformation, in the previous classes we have seen echelon form, remember? What is echelon form? In a given matrix, yes, number of zeros of the it is not preceding matrix, man. the number of zeros before the non-zero elements of a row is less than the previous row. Okay, like that I gave some. The thing is, we should make like here three, like A1, B1, C1, A2, B2, C2, A3, B3, C3, like some elements are there. Means we should make these triangle as 0, no triangle as 0. Okay, so than the previous row, it will be having less number of zeros. Sorry, than the next row, it is having less number of zeros. So this row is having 2 zeros, means this will be 1 less. This row is having 1 zero, means this will be no zeros. This should be non-zero element. Okay, that is it. That is what echelon form. And then equivalent matrix. Equivalent matrix. We have seen equality of matrices, right? So when the two matrices are equivalent, means like 3 by 4 is a fraction and 12 by 16 is equivalent fraction, right? Why? Fractions and equivalent fraction. This is being multiplied with 4. Okay, existing thing multiplied with something, transformed. So like that, we are doing like this elementary operations and getting new matrices, means that matrices are called equivalent matrices. Okay, that is it. And we'll see one example. We should find the rank of this matrix. Find the rank of this matrix A 1, 2, 1, minus 1, 0, 2, 1, 1, minus 1. Sorry, 0, 1, minus 1. I think we have already solved this question, right, in the previous class. We have taken the determinant and it became non-singular. You check it. Then the rank is 3, like we decided, right? Now we will solve the same question by elementary row operations. Let me check the question once again. It is 1, 2, 1, minus 1, 0, 2, 0, 1, minus 1. Yeah. Now we will use some elementary operations. Now we are going to solve this using elementary row transformations. Okay. The first idea is to get 2 zeros here. Yes, same. Okay. See, that I forgot. Two matrices are said to be equivalent, then A is equivalent to B. Like how we will denote, means the matrix A is equivalent to B, like we will denote. Okay, this is matrix A. Whatever the row operations we are getting the new matrix, they are said to be equivalent matrices of this. So after this, we won't put this equal to sign. Now I am starting with A equal to, right? Next time, while I am applying some operations, I will use this one. This is an equivalent matrix. So equivalent matrices are having the same rank. Alright. So now try to get 2 zeros here. So this element should become 0. Is it possible to make this 0? This one. Row 2 or column 2? Yes. See, first we should write which column we are going to apply the change. It is on column 2. Okay. After that, what operations we are going to do? We are going to add column 2 plus column 3. Okay. C2 plus C3 written. Okay. Now, first column I can write as it is. And the second column I am going to rewrite by adding these two. So, that is 2 plus 1, 3, 0 plus 2, 2, 1 minus 1, 0. And we get third column as it is. It is not changed, right? Only the second column changed. So we got 2 zeros. Next we will try to get 1 0 here. How to get another 0? We'll write the result in the R2, row 2, and we can add R2 with the R1. Okay, because these two things can be added, no, that will become 0. So first row remains unchanged. Second row, these two can be added and written. Plus 1 minus 1, this 0, 3, 2, 5, 1 plus 2, 3, 0, 0, minus 1. Okay. So we got this one. It is a echelon form. Is it? In this echelon form, how many number of non-zero rows are there? That is our rank. Okay. So here number of non-zero rows are what? 3 rows are there. First row, like non-zero means 0. It is not that not having 0. An entire row is 0, right? That is only said that 0 row. Like that we don't have any row, because here at least one element is non-zero, right? So we can calculate. So 3 rows are having non-zero entries. Is it? Not all 0. So here the rank is 3. Suppose this also has become 0. Suppose, just in case. Now number of non-zero rows is what? Will become 2. Why? Because this is having full of 0 entries. This is a 0 row. Non-zero rows. This is not fully 0. That is what it counts. Okay. Alright. Any doubts on this? Okay. Perfect. So next one. We'll see one more example. Shall I erase this? See, we should find the rank of 1, 0, 2, 0, 1, minus 2, 1, minus 1, 4, and 2, 2, 8. What is the order of the matrix? This 4 by 3 matrix. So the rank of the matrix can be less than or equal to minimum of 4 or 3. This can be less than or equal to 3. Okay. But we have 4 rows here. We'll see. And here we should get zeros, man. As many as possible. Okay. As it is having 1, 2, 3, 4 rows. Try to get, did I wrote the question correctly? Oh, yes, correct. Okay, try to get the row echelon form. So, here 1 0 is there, here 2 0 may be coming, here 3 zeros may be coming, we'll check. Okay, so is it possible to make this element 0? Yes, how? Because I am focusing from the upside. Okay. Now I am going to take R3, this R3, wait, R3 minus R1 is enough, right? Now another also we can do, R3 minus, 2 times R3 minus R4 we can write, okay, or R1 minus R3, no problem, still it is same, okay. No, that like and all you should not do. It should be involved only 2 rows at a time. You should not include more than 2 rows. Okay. So simply R1 minus R3. What is R1 elements? R1 is 1, 0, 2. R3 elements 1, minus 1, 4. Yes. Okay. Okay, then we'll check. It's better to use only 2. Okay. Now we'll add these two, not add, subtract. So subtract means here minus, this is plus, this is minus. So this will be 0 and this will be 1, this will be minus 2. This is our new row. Okay. So we'll use this. First row remains unchanged, 1, 0, 2. Second row remains unchanged, 0, 1, minus 2. And third row remains, third row we only changed, right? 0, 1, minus 2. And this one, 2, 2, 8. Okay. Now what do you observe? Yes, still this 0 can be made, right? To make this is 0. Yes. Okay. This can be made 0 by simply subtracting these two. Now I am going to perform R3, not R3, I am going to write the result. R3 minus R2 I am going to write. Okay, what is R3? 0, 1, minus 2. R2 is 0, 1, minus 2. When we subtract, this is minus, this is minus, this is plus, 0, 0, 0 will come. Okay. So this is 1, 0, 2 remains unchanged. This is 0, 1, minus 2 remains unchanged. This is 0, 0, 0 came. 2, 2, 8. Is this row echelon form? No. So interchange R3 and R4. We interchange R3 and R4. Why? Because now based on the number of zeros, 1, 0, 2, and this is 0, 1, minus 2. Now this is 2, 2, 8, this is 0, 0, 0. Okay. Now is it possible to make this element 0 or not? We check. Okay. Is it possible to make this element 0? R3 we will take. And R3 minus 2 times R1, because here 1 is there. This can be multiplied with 2 and can be subtracted. Okay. R3 is 2, 2, 8. 2 times R1, 2, 0, 4. They can be subtracted. 2 minus 2, 0. This is 2. This is plus 4. Okay. Then 1, 0, 2. 0, 1, minus 2 as it is. Here 0, 2. 4, 0, 0, 0. There should not be equal number of zeros again. This also can be made 0 or not, you should check. Okay. It should be less than the next row, right? Yes. R3 minus. No. Oh, wait. R3 implies. R3 minus 2R2. So R3 is 0, 2, 4. 2R2 is 0, 2, minus 4. Is it? And we have to subtract. Subtract means this is minus, this is minus, this is plus. So we will get 0. Here 0. Here 8. So 0, 0, 8. 1, 0, 2. 0, 1, minus 2. This third row becomes 0, 0, 8 and 0, 0, 0. Now we got row echelon form, right? So 1, 0, 2, 0, 3 zeros. The number of zeros in the next row will be less than the previous row. Okay. Sorry. The number of zeros in the previous row will be less than the row. Okay. So number of non-zero rows, yes, 3. We say the rank is 3. It is denoted by row, man. This row is like one symbol, right? That is what rank of a matrix is. This row of A means rank of a matrix. Okay. Any doubts on this? Now, this is an example question. You just match it with the example in the book and what we have done. Or we did the same thing or different one? So the thing is, it is not that what operations we are applying. Ultimately, at last, we will get the answer. Okay. Can I raise everything? Okay. Now, do you have any doubts in this? You said that 4 by 4, 4 by 4 like that. Okay, perfect. Now we'll see one more type of question and then we'll move to the next topic. Find A. Find A such that the rank of A is 2, or the matrix A is 2 1 1 2 and 3 0 minus 1 4 7 2 A 8. Alright, now the matrix is having 3 rows. Okay, the rank is 2. That means last row is 0. So A must be 0, like we may think, but it is not. Okay, because that is happens in the equivalent matrix. Okay, we will try to obtain row echelon form. Okay, after that we will decide. Okay, so row echelon form is what? See here the numbers are different. Then here if 1 is there means it is easy, because we can easily relate to the number and we can do. Okay, so what I am doing is, no, I am just interchanging the column 2 and the column 1. Then it is equivalent to, this is 1 0 2 and 2 3 7 and 1 minus 1 A 2 4 8. You get it? Now I got 1 here 0, then these 2 zeros obtained only enough. Okay, now this place should become 0. So we will apply R3. I am going to apply the result, that is R3 minus 2 times R1. So R3 we have 2 7 A 8, R1 2 times R1, that is 2 4 2 4, that is subtracted. When you subtract, 2 minus 2 will become 0, 7 minus 4 3, this is A minus 2, 8 minus 4, which is 4. This is our new R3. Then we can write, which is equivalent to 1 2 1 2 0 3 minus 1 4, new R3 0 3 A minus 2 4. Okay, now this place should become 0. Now hereafter we don't relate with the first one, second one we can relate. That is really simple. I am going to write the result in R3 in the manner that R3 minus R2. Why R3 minus R2? These two can be subtracted, can be made 0. So R3 is 0 3 A minus 2 4, R2 is 0 3 minus 1 4. Subtract, this is plus. Is it? So when we subtract, here 0, this is A minus 1, this is 0. Okay, what is? Wait, we'll discuss. We'll try what we thought. Rank is 2, they gave. I'm trying to obtain the row echelon form. Okay, that's what I'm doing. So row echelon form here 1, 2, 1, 2, 0, 3, minus 1, 4. New row is 0, 0, a minus 1, 0. Okay, this is the row echelon form, is it? Now, they said the rank is 2. That means this last row must be full of zeros. Why I am coming into that conclusion? Because here this is the only element. Okay, so that means this a minus 1 must be 0. Then a will be 1. Okay, that is it. The same way other questions also there. See, again you just look into your book. They have gone with some other operations, but we have did separately, right? Okay. Now the same way all the things. Okay, in that exercise 3.6, short answer, last question, you just look into it. What is rank of that matrix? With the full entry is 0. While saying in the definition itself, I said the rank of a null matrix is defined as 0. Okay, that is it. So that is about the rank of a matrix, and then we'll move on to the next topic.